Good morning class, my name is Vikas Kumar, Maths faculty of Samarth Academy, and today we are going to discuss about the equation of tangent of the various conic sections such as circle, ellipse, parabola and hyperbola. Okay, and after finding out the equation of the tangent, we will going to discuss about what? About the shortcut method to find out the equation of the tangent. Okay, so in that shortcut method you need not to remember each and every process. Okay, so let's start. Now this is the circle, the first conic section, that is what? Having the equation x square plus y square is equal to what? R square. In this case we have a center of what? 0 comma 0 and radius is equal to what? R. So in this case just suppose a circle like this. Okay, a circle like this having origin at the center, so it's like this. So this is your plus y and this is your minus y, this is your plus x and minus x. Understood? Minus x. So in this case this is your what? Center, which is your origin. Now this is your radius. Understood? Now just take it a tangent on it and let's take it the general point, you can say x1 comma y1. So we have to find out the equation of this tangent. Now step number one, okay, the same steps will be repeated in case of ellipse, in case of parabola or in case of hyperbola. Understood? Now step number one, find the slope of tangent. Understood? In this case, to find out the slope of the tangent, so we all know that for a straight line we have a very good formula, that is slope is equal to what? Change in y-axis upon change in x-axis. But in case of the curves we have to use the differentiation, because there is a small change in y-axis and small change in x-axis. Okay, so in this case we have to use the differentiation to find out the slope. Understood? Now let's take it. Now let's differentiate the equation. So we have the equation x square y square is equal to r square. Now differentiating on both sides, so we will have dx square upon dx, now dy square upon dx, now dy upon dx. Understood? So it can be written as dy square with respect to y and then y with respect to x is equal to what? dr square upon dx. So let's differentiate it. So we have the formula of x to the power n in case of differentiation, that is what? N multiplied by x to the power n minus 1. So let's take it, that is what? 2, instead of n we have the value of 2. So in that case 2 into x to the power 2 minus 1 plus this is what? 2. Now 2 will be your coefficient and there will be a subtraction of power 1 in case of y. Now dy upon dx. Understood? So it will be, now as we know that differentiation of any constant is equal to what? 0. Here the radius is what? Constant. This is not the variable circle, this is a constant circle. How can we identify it's a variable or constant? It is only because of the radius. If the radius is variable, the circle is variable, and if the radius is constant, the circle is constant. Okay, just suppose if I am dropping a stone in the water. Understood? So in that case there are concentric circles and these circles are what? Of variable radius. These circles are of variable radius. So this is the basic, or you can say common example of the circle having variable radius. So that's why the point at which the stone falls into the water, so in that case that is your center, and from that center there are so many circular waves in the water is produced and after some time it will be vanished. So in this case these are called the variable circles. Understood? Now this radius is constant, so as we know that radius having the differentiation with respect to x, that is equal to 0. So we are left behind with 2 multiplied by x and then again 2 multiplied by y into dy upon dx, that is equal to 0. So in that case, after calculating you will get dy upon dx is equal to what? Minus x upon y. So find out the slope of the tangent at point x1 y1. So because you have to find out the slope at x1 y1. So in this case, slope at x1 and y1 is equal to what? Minus x1 divided by y1. So this is, just put the value of x1 y1 into the slope. So in that case, this is considered as the slope of the equation of tangent. Understood? Now this is the step to find out the slope of the tangent. Just differentiate the given equation. Understood? And then finding out dy upon dx, which is representing what? Slope of the curve. So in that case, just find out your differentiation at the given point, okay, at x1 y1. So now this tangent is a straight line, and we have so many equations to find out the equation of the straight line, such as your slope point form. Understood? It means we are going to discuss about the step number 2. So we have, this is step number 1, to find out the find out the slope. Understood? By using the differentiation method. Understood? Now step number 2 is use slope point equation of straight line. Understood? Use slope point equation of the straight line. So in that case, we have the equation what? Y minus y1 is equal to what? Slope multiplied by x minus x1. So here the slope is equal to what? Dy upon dx at x1 comma y1. So we have x1 upon y1 minus of x1 upon y1. So that is the slope of the equation, and which point is given? The point is x1 comma y1. So you have the slope, okay, and you have the point also, because that point is what? That point is your point of contact of the tangent with the circle. So that is given in the question. That is what? X1 y1. So we have the point x1 y1, we have the slope is equal to what? Minus x1 upon y1. So just put the value and get the result. So it will be equal to what? Y minus y1 is equal to what? Minus x1 upon y1 multiplied by x minus x1. So in this case, this y1 will be multiplied. So y1 and minus y1 square is equal to what? Minus x1 x, and this minus plus x1 square. So now variable on the LHS side, constants are on the RHS side. So in this case, we are going to transfer this x minus x1 on the LHS side. So it will be going to be plus. So in this case, x1 y1 is equal to what? X1 square plus y1 square. Now we have the value of x1 square and y1 square. How? Just find. We have the equation what? X square y square and then is equal to r square. Now this x1 y1 is the point on the circle. So that means x1 y1 is satisfying the equation of the circle as well as the equation of tangent. Understood? Because that's the common point. Okay. So in that case, x1 comma y1 is what? Satisfies the equation of circle. Okay. Satisfies the circle. So in this case, just put x is replaced by x1. So x1 square, and then y is replaced by y1. So that means it's y1 square is equal to what? R square. Understood? So we have the equation x1 then again plus y1 is equal to r square, which is the required equation of the circle. This is the equation of tangent on the circle. This is the equation of tangent on the circle. Which type of circle? Center radius equation of the circle. that is equal to what? X square plus y square is equal to r square. So x square is replaced by x1, y square is replaced by y1 is equal to what? R square. So this is the required equation of the tangent of the what? Circle. Now let's come to the so just take a review on it. We have two steps. Okay, first one is what? Step number 1, to find out the slope of the equation, okay, at point x1 and y1. So in that case, we have to differentiate the given equation and then finding out the dy upon dx, which is representing the slope of the curves. Okay, now this dy upon dx, find out the dy upon dx at x1 y1. So we have minus x1 divided by y1, which is a constant. Now step number 2 is what? Use the slope point equation, because the point is given in the question x1 y1 and we have the slope is equal to what? Minus x1 divided by y1 from the previous step, and then putting all the values in this equation, we have x1 plus y1 is equal to what? X1 square plus y1 square. Now this x1 and y1 is on the circle, is the point on the circle. So that's why this x1 y1 satisfies the equation of the circle. So we have x1 square plus y1 square is equal to r square, and that is what? Is equal to what? That is equal to r square. So this is the given equation of the tangent. Okay, thank you class. So this is it. We have the equation of the tangent of the circle like x1 y1 is equal to r square. Thank you everyone.